Alright, so this program is the main mean, median, and mode program. Obviously, it's going to find the mean, median, and mode of two different arrays. And I do two different arrays because with the median, you're looking at the middle. The algorithm to figure it out is different based off of if it's an even number of elements in your array or an odd number of elements in your array. So we gotta test out two of them, so I just do it for all of them. Alright, so we've got our variables that we'll use up here, and I kind of pre-built some of this because, you know, the videos are pretty long and I'm trying to cut them down a little bit. So you got your variables, you got your two arrays. I just threw in whatever numbers. You got the size of the numbers 1 array and the numbers 2 array. Okay, so you definitely need to know how to figure out the size of an array. So that's important. And then I've got setmean, setmedian, setmode that gets passed in an array and the size, and a getmean, getmedian, and getmode method. So first one, we pass in numbers 1 and the numbers 1 size, numbers 1 mean, and we get the mean. Set the mean for the numbers 2 array, pass in the size again, and then we get the size, or get the mean. So, alright, so we have our methods down here. And when I get to these, I'll uncomment them, but right now it should be good. Alright. So, let's see here. So to get the mean, you need to sum up the numbers, and then you can divide them by the number size. So I'm going to do sum equals 0 and mean equals 0. And we'll do a for loop. We'll say int I equals 0. I is less than the number size that gets passed in, numbers size. I plus plus. This is by far the easiest one. So we just do sum plus equals the numbers. That's your array at position I. So that would add them all up. And then right here, we can say mean is equal to the sum divided by the numbers size. And then all we need to do is just return the mean. So that one's really easy. All we do is do a loop, run through each one, and add them to sum. Then we say mean equals sum divided by the number size. So let's run this. And so we should get 575. Now, I don't know, let's just test one of them so that I feel good about and make sure that things are good here. Okay, so 4 plus 2 is 6, plus 3 is 9, plus 5 is 14, 15, 16, 26, 36, 46. So I got 46 divided by, what do we got? 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8 is 5.75. Okay, so I know that works. Alright, so next up, median. This is much more difficult. All right. So this one will just return the median. That's your return method. So that's really easy. This one's really easy too, because all you're going to do is return the mode. Alright. Excuse me. Alright, so we're going to say the median is equal to 0. We're going to have a temp variable equal to 0. And I'm going to have a values equal to the numbers size divided by 2. And why do I do that? Let me think here for a minute. To find the median, median is the middle point. So this has 1, 2, 3, 4, 5, 6, 7, 8. If we do 8 divided by 4, 0, 1, 2, 3, 4, 5, 6, 7. So the size is 8. If we divide that by 2, we get 4. So in this case, 4, you know, that's not the middle. Okay, the middle is 1, 2, 3, and then you got 3 over here. So the middle are these two numbers. Okay, because it's an even one, you got to take the two middle numbers and divide them by 2. This one has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And so 7 divided by 2 is 3.5. But remember, we're working with integers, so it's just 3. So position 0, 1, 2, 3, that clearly is the middle number, all right? So we are going to have to do something about, you know, if it's an even number or an odd number, and then we'll take the values and do something with that to figure out our index position, okay? So I just did that there. But before we can even get to that, we have to sort our array because it's the middle number after the array is sorted, okay? So in order to do our sort, okay, we're going to have nested loops, okay? I'm going to say int I equals 0, I is less than the number's size, I plus plus, and I'm going to say int x equals I plus 1, and I'll show you why I do that here in a second. And then x is less than numbers size x plus plus. Okay, so why did I do that? Well, in order to sort this thing, I'm going to have to look at this number, and then I'm going to have to compare it to this one. And if this number is greater than this number, I'm going to have to swap them, okay, which it is. So then, you know, our you know, the first time through, do this. Let me see if I've got mode here. Miscellaneous. No, I'll just do it right here. Okay, so let's think about this. So we're going to have to take this number and check to see if it's smaller, right? And if it is, we'll swap them. So then we would have 2, 4, 3, 5, 2, 10, 10, 10, okay? So we got to take whatever number we're in and then swap it and then keep comparing, because, you know, what if this was 1 right here? Then we would have to swap these ones, okay? So, and then we'd have to go to the next index position, and so, let's do this. Let me write some code and you'll kind of see how this works. So again, the outer loop is going to be at position 0, but the inner loop is going to start at position 1 and run through each one and compare them, all right? So we'll say if the numbers at position I are greater than the numbers at position X, then we have to set a temp variable. Our temp variable will be the numbers at position I. Okay, so again, we'd have to, this would be our, since this is greater, this is going to be put into our temp. Okay, then the numbers at position I are going to be equal to the numbers at position X. Okay, so the numbers at position, so this number, which was 4, is going to be assigned to the 2 right here. So that gets assigned, all right? But that blew out, okay, that blew out this numbers at position I. That's why we kept this temp number, okay? Because now what we want to do is we want to say the numbers at position X is equal to the temp value, okay? So that's how you swap, okay? If I didn't do that, what would happen is, if I didn't have this line, if I commented that out, okay, then what would happen is you'd have 2 being assigned right here. So it'd be basically, it would look like this. It'd be 2 and then 2. And then when you went to assign X to, you know, well, you couldn't even do that there because we wouldn't have a temp value. You could say X, the one at position, you could try doing this instead. You could do, you know, young programmers will try doing this without the temp value. But what happened here? We assigned this value to 2. So now it looked like that. So when we go into the X value right here, it would just be equal to what's at I, which is 4, or which is 2 now. And so you would have this, and you wouldn't be able to store what's in position 0. Okay, so we need that temp value to do that. Okay, so that swaps them. Okay, all right, and so then it's going to go, you know, it's going to add 1 to X. I is still, let's change that to 4. I is still 0, so we just did what's in position 1, and then we added 1 to X, and so now that's 2. Is this greater than 3? No. So again, then we add 1 to X, and now we're X equals 3. Is this greater than 5? No. And so we would just keep going through this the whole time, okay? And so then we would run all this the way through until X would be equal to the number size, and the Boolean condition would hit. So then we would go back up, and now X would be set to, or sorry, I right here would be set to 2. Sorry, it would be set to 1. Okay, it'd be set to 1. So now what we got to do, this would be set to 1. 1 is less than the number size, so we go back in and we do 1 plus 1 is 2. So now we're looking at this, right? And so then we've got to then swap. That would be done. We'd swap this. This would be 4, and this would be 3. Sorry, that'd be 4, 3, and then 4. And then we got 5, 2, 10, 10, 10, right? And so we're still at position 1 for I, but X would then go here, right? Sorry, it would go here. 3 is not greater than 5, so then it would go here. 3 is greater than 2, so then we got to swap those. So we'd have 2, 2, 4, 5, and then 3, 10, 10, and then 10. And then it would just, sorry, this would be what, 2. I screwed that up. That'd be 2 because I forgot I didn't swap that right. So now we have 2, 2, 4, 5, and then you can see I would become 1 eventually, and then you're gonna, you know, you'd look at these, and then you would swap these two. So you're just doing. You have to have an outer loop that sticks with this and then runs through everything in the list. So the inner loop runs through everything in the list. Okay. So that's how you sort that. Okay, and you know, if you want to test to see if sorted correctly, you could do a for loop and do, I don't know, int I equals 0, I is less than numbers size I plus plus, and then you do what? Cout, you know, test, what is it, numbers, yeah, position I. Okay, so let's run that real quick. 2, 2, 3, 4, 5, 10, 10, 10, and then numbers, the median, I didn't figure that out yet. Then test 1, 2, 2, 2, 3, 4, 5. Okay, so let me look at that real quick. 1, 2, 2, 2, 3. Okay, so yeah, it looks good. So that test is good. So then what do I do here? I just comment that out for now. All right, so that gives you the sort. So now what we got to do is we got to check if it's an even or odd array value. So if if number size modulus 2 is equal to 0. Okay, so let's think about this. If our array is an even number, okay, so let's say it's at 8. 8, how many times does 2 go into 8? So remember, modulus looks for a remainder. 2 goes into to 8 4 times with a remainder of 0. So that's an even, okay? Else, so that this would be to check if it's an even number of elements. Else, this checks to see an odd number of elements. Okay, so let's think about this. So we would say the median is equal to, for even, let's think about this. Let's get this, let's just, you know, dot, 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 and then just assume that it's sorted. So it'd be what, 2, 2, 3, 4, 5, 10, 10, 10. So median, so there's the first 3, there's the last 3, and here's that. So number size, so if we have our index 0, 1, 2, 3, 4, 5, 6, 7. So that's 8. 8 divided by 2 is 4. So this is one that we do want, but we want the prior one. We want to take the prior one and this one, add them together, and divide it by 2 to get 4.5. Okay? So what we need to do is we need to take the numbers at the value minus 1. Because remember, we got up here 8 divided by 2 is 4. And what's in index position 4? It's 5 right here. We want what's in 3 first, index position 3. So I do that, subtract that, its value values minus 1, okay? And then what do? We do plus the numbers at values. So that's the number 5 there. And then we just divide it by 2, okay? Else, if it's in the even number 1, okay, let's sort this one real quick. We'll say index, and we'll do what? This is 1, 2, 2, 2, 2, what, 4 and 5? No, 3, 4, and 5. So that's 7 elements in it, okay? So 7 divided by 2 is 3.5, but they're ints, so you get rid of that 0.5, so it's really just 3. So what's in position 3? That's the middle. You have 3, 1, 2, 3, and you have 3 afterwards. So you just have the values right here. So if it's an odd number, you would say median equals the numbers at the values. Okay, and then we get it. So let's check this. It should be 4.5 and what, 3? 4.5 and 2. Yeah, 2 right here at position 3. It's a 2. Okay, so that looks good. All right, that's actually pretty hard to do. The sort is hard to do, especially for you newcomers. Again, think about it. You have to be, the outer loop's going to do, it's going to stick to one number, and then the inner loop will run through the whole thing and compare that first outer loop number to everything inside of it. And then it will switch to the next number, and then everything, it will compare that next number in the loop to everything inside of it. Okay. So mode is also not the easiest one, but I don't know. It's not that bad either, I guess. I don't know. So mode is the one that's most used. So the most used in the first one is 10, and the most used in the second one is 2. Alright, so we'll say mode equals 0. We're going to have a counting equals 0, and a max count equals 0. And we'll have a for loop, another nested for loop, because we gotta, have our outer loop lock in a number and then check to see if the other ones are equal to it, to see if there's more, and if there are, then we'll count them all up. So I'm going to say int I equals 0, I is less than number size, I plus plus, and this will be same kind of thing. Only we'll do int x equals 0, and this will just give us our count to be at least 1 for each one. Okay, so I'm going to say if numbers at I is equal to numbers at x, we'll counting plus plus. So if whatever's at I is equal to x, so the first time through, this numbers are going to be the same, so we'll have 1 to count. And then after your if statement, no, actually, let's think about this. We've got to do the max count. Okay, if the counting is greater than the max count, then the new max count is equal to counting. And after that, we just set counting back to 0. Okay, so how is this working? So you're looking at this original, all right, and I is 0, so then x would be 0 as well. So is what's at I and what's at x both 4? Yep. So counting, that'd be 1. Okay. And then is there another 4 here? There's no, like, so then it would go, okay, cool. So now x becomes 1, and is what's at position 0 equal to what's at position 1? No. So you go x becomes 2. Is what's at position 0 equal to what's at position 2 here? No. So it'd run through all of them, but at 4 becomes your new largest number, okay? So counting is greater than, so the max count is what? It's what's at position 4 now? What we need to do is we need to, what I missed here, let me think. We didn't get the index position, so that's what the mode was for. So I'm going to do mode is equal to numbers at position I. Okay, I did forget to do that. So then basically what it would do is it would get to this, so then it would get here, and is what's at position 1 equal to 0? No. Is what's at position 1 equal to 1? Yes. So counting would be 1. And then you compare it here. No. Here. No. Here. Yes. So counting would become 2. And then it would compare here. No. Here. No. And then here. No. And so counting is now 2. Is 2 greater than the max count of 1, which we had with 4? It is, so what's at position I? It's 2, so the mode is now 2. And it would run through this and then it'd do 10, and so the counting would be 3. And so, then the index position would be 5, which would be 10. Alright, so let's see here. You probably need to run through that in your head and kind of see what's going on, but 10 and 2 are definitely my modes, the most often used number. So 10 right there, and the 2's right here. So anyway, everything tests out okay on this. So plug this in and try to get this to the best of your ability. Again, this is kind of basic stuff after you do it for a while, but it's definitely confusing the first time you try it, so you'll probably have to plug away and think through how to do that, and maybe watch the video more than once. So anyway, this video is done.